NVIDIA has announced the beta release of Newton, an open-source physics engine specifically designed to bridge the critical sim-to-real gap in robotics development. This major announcement was made at the Conference on Robot Learning in Seoul, South Korea, and represents a significant collaboration between NVIDIA, Google DeepMind, and Disney Research aimed at accelerating robot learning and deployment capabilities. Newton is now integrated into NVIDIA Isaac Lab and managed by the Linux Foundation, positioning it as a foundational open-source tool for the robotics community. This initiative addresses one of the most challenging aspects of robotics development, ensuring that skills and behaviors learned in simulation transfer effectively to physical robots in the real world, a problem that has long hindered robotics progress. Newton delivers revolutionary performance improvements that dramatically accelerate robotic simulation and training. The MuJoCo warp solver within Newton achieves up to 152 times faster performance for locomotion tasks and an astonishing 313 times faster performance for manipulation tasks compared to existing solutions when running on GeForce RTX 4090 hardware. The performance gains extend to professional workstation hardware as well, with the latest NVIDIA RTX Pro 6000 Blackwell series adding another 44% speed improvement for MuJoCo Warp and 75% for competing frameworks. These massive performance gains enable robotics researchers and developers to run simulations orders of magnitude faster than previously possible, dramatically reducing the time required to train and validate robot behaviors. This acceleration is crucial for developing complex robotic systems that require extensive training and testing in simulated environments before real-world deployment. NVIDIA's vision for robotics development centers around what they call the three computers needed to bring robots from research into everyday life. As explained by Rev Lebedarian, NVIDIA's Vice President of Omniverse and Simulation Technology, humanoids represent the next frontier of physical AI, requiring the ability to reason, adapt, and act safely in an unpredictable world. The three essential components are Isaac GROOT, serving as the robot's brain for AI reasoning and adaptation, Newton, simulating the robot's body through accurate physics modeling, and NVIDIA Omniverse, providing the training ground where robots can learn and practice in virtual environments. This comprehensive ecosystem addresses the complete robotics development pipeline, from initial AI training through physical simulation and finally to real-world deployment, creating an integrated solution for developing capable and safe robotic systems. Newton is built on NVIDIA Warp and OpenUSD frameworks, providing advanced technical capabilities that enable complex multiphysics simulations previously difficult or impossible to achieve. The engine supports simulations involving deformable objects, cloth, and granular materials like sand and gravel, allowing robots to learn interactions with a wide variety of real-world substances. A key technical innovation is Newton's differentiable physics capabilities, which enable gradient-based optimization. This allows robots to learn more effectively from simulation data by understanding how small changes in actions affect outcomes, significantly improving the efficiency of training processes. The GPU-accelerated architecture ensures massive parallel processing capabilities, while the OpenUSD framework provides interoperability across different platforms and tools, making Newton accessible to a broad range of developers and researchers working in the robotics space. The industry response to Newton has been immediate and widespread, with leading robotics companies and academic institutions quickly adopting the technology for their development workflows. Boston Dynamics is using Newton's new dexterous grasping workflow to improve its Atlas robot's manipulation capabilities. Other major industry adopters include Agility Robotics, Figure AI, Hexagon, Skilled AI, Solomon, and Techman Robot. Academic institutions are also embracing Newton, with ETH Zurich's Robotics Systems Lab leveraging it for multiphysics simulation in earth-moving applications. Technical University of Munich using it to run trained dexterous manipulation policies validated on real robots, and Peking University integrating its tactile sensing solver, TacCell, with Newton to advance vision-based tactile robotics. As Jim Zemlin, executive director of the Linux Foundation, noted, bringing Newton to the Linux Foundation marks an important step forward for scaling collaborative robotic simulation. Newton addresses the fundamental sim-to-real challenge in robotics development, which involves ensuring that skills learned in virtual environments successfully transfer to physical robots. This challenge has been a major bottleneck in robotics progress, as differences between simulation and reality often cause trained behaviors to fail when deployed on actual hardware. Newton helps overcome this through more accurate physics modeling and GPU-accelerated performance that enables training on scenarios that would be too costly, rare, or dangerous to reproduce in the real world. Robots can be trained on hazardous situations safely in simulation. Rare but critical events can be simulated repeatedly, and the need for expensive physical prototyping is significantly reduced. The more realistic physics simulation improves the transfer of learned behaviors from virtual to physical environments, accelerating the development of capable and reliable robotic systems. Newton represents a crucial component in NVIDIA's strategic push into what the company calls the trillion-dollar physical AI market. This market encompasses the integration of artificial intelligence with physical systems, including robotics, autonomous vehicles, and other intelligent machines that interact with the real world. The combination of Isaac GROOT for AI reasoning, Newton for physical simulation, and Omniverse for training environments creates a complete ecosystem that will accelerate the development of capable, safe, and adaptable robots for real-world applications across industries. As an open-source initiative backed by major industry players and managed by the Linux Foundation, Newton is positioned as a foundational technology for the next generation of robotics development. This approach encourages community collaboration, standardization, and rapid innovation, potentially accelerating progress toward truly capable physical AI systems that can operate effectively in complex, unstructured environments.